You know, when we think about what makes an app or a piece of software great, our minds usually jump to the slick design or some really clever code, right? But what if I told you that the success or failure of a project is pretty much decided before anyone writes a single line of code? Today, we're going to pull back the curtain on the invisible architecture behind all great software, system analysis.
Whoa, that's a pretty big claim, Jane. I mean, we've all been there, right? Fighting with an app that's just confusing or a website that doesn't do what you think it should. Are you saying that's not just bad coding?
Most of the time, nope. It's usually a problem with the blueprint. I mean, think about it. You wouldn't hire a construction crew and tell them to just start building a house without a detailed plan, would you? Software's no different. So here's what we're going to cover. We'll kick things off by talking about what system analysis actually is. Then we'll get into how we model a system to really understand it, check out the tools of the trade, and finally wrap up with why getting this blueprint right is just so incredibly important.
All right, so let's start at the very beginning. What in the world are we even talking about when we say system analysis?
Okay, that definition sounds a little academic, I know, but it's actually pretty simple. It's all about creating simplified drawings or diagrams. We call them models. These models help us, the tech people, understand all the things the system needs to do. But maybe even more importantly, they create a common language. That way, the developers, the business folks, and the actual users can all look at the same plan and know they're talking about the same thing.
Got it. So that brings up a question I hear all the time. Where does the analysis part stop and the actual design part begin? People seem to mix those two up constantly.
That is a fantastic question, Alex. And you're right, it's a huge point of confusion. Here's the key difference. Analysis is all about the what. What does the business need? What problem are we trying to solve? What features does it absolutely have to have? Design, on the other hand, is all about the how. How are we going to build it? What programming language? What database? How will all the pieces talk to each other? You simply can't figure out how to build something until you know exactly what it is you're supposed to be building.
And the main way we figure out that what is by creating those models we just talked about. This is really where the magic happens, where we take a really big, complex idea and start breaking it down into pieces we can actually understand and talk about. Okay, so a model isn't trying to show the entire system all at once. It's more like a specific map for a specific purpose. You nailed it, exactly! You can't show everything on one single map of a city. You might have a road map, a subway map, a tourist map. Each one shows a different perspective, a different story. System models are precisely the same.
And generally, we create about 4 main maps, or perspectives. The external one shows us where our system fits into the big, wide world. The interaction view is all about how it talks to users or maybe other systems. The structural perspective is kind of like an X-ray, showing all the parts inside. And finally, the behavioral perspective shows how the system actually acts and reacts when things happen. Put them all together and you've got a really complete picture. Now, to draw these maps, analysts don't just grab a napkin and a pen. Well, sometimes they do it first. But to do it professionally, they use a standardized toolkit. And the biggest, most important tool in that kit is called UML. So UML, which stands for Unified Modeling Language, is pretty much the universal language for software blueprints. It gives everyone a standard set of symbols and diagrams so that any software engineer on any team anywhere in the world can look at a design and know exactly what it means.
Okay, so what do these blueprints actually look like? I'm guessing there are different kinds of diagrams for different jobs?
Oh, for sure. UML actually has more than a dozen different diagram types. But in reality, most of us rely on a handful of key ones. And these are some of the heavy hitters, the ones we use all the time to represent those different perspectives we were just talking about.
So, for example, a use case diagram is the perfect way to show that interaction perspective. It basically shows what a user, or an actor as we call them, can do with the system. So for a shopping app, you'd have use cases like search for an item, add to shopping cart, or process payment. It's all about the what, but from the user's point of view. This one looks a lot more technical, more internal. This doesn't seem to be about the user at all.
You got it. A class diagram is pure structural perspective. It's that internal blueprint. It shows the main building blocks of the software, the classes, and how they're all connected to each other. It's like the schematic that shows a car's engine, its transmission, and its wheels, and how they are all physically bolted together.
And then, if we want to show how all those parts actually work together to get something done, we pull out a sequence diagram. This shows the behavior. It's literally a step-by-step, blow-by-blow account of how different pieces of the system talk to each other to complete one task, like making an online purchase. Honestly, it's kind of like a comic strip for code.
Okay, so we've got all these diagrams, these models, these perspectives, but let's zoom back out for a second. Why does all this matter? Why go through all this effort to draw a bunch of boxes and lines before we can start coding?
Yeah, that's the bottom line, right? What's the big payoff here? Why can't a bunch of smart coders just, figure it out as they go?
Because, as this quote says so perfectly, this whole analysis phase is the bridge. It's the critical link that connects the business idea, the requirements, to the technical plan, the design. If you don't build that bridge, you get what we see all the time, a system that's maybe technically impressive, but that completely fails to solve the actual problem it was meant to solve.
And the benefits are so real. Good analysis isn't just a nice to have, it saves a staggering amount of time and money. Seriously, there are studies that show a bug that costs, say, $1 to fix when you find it in the analysis phase can cost hundreds, maybe even thousands of dollars to fix after the software is already out in the wild. It is literally the difference between erasing a line on a blueprint versus taking a sledgehammer to a concrete wall.
So, the next time you open up your favorite app, the one that just works, it feels intuitive, it's reliable, it does exactly what you need it to do, just take a second and think about this. Is its success really just because of some clever lines of code? Or is it because it's standing on the invisible, solid foundation of a truly brilliant blueprint?